Okay, in this video, we are going to talk about some basic concept of the exponential function and the exponential graph. Okay, let's do some revision. The meaning of exponential function is there's a constant as a base, we call it as a usually, and the power will be the variable x. So if we try to sketch the graph of the exponential function, it will come out something like this. You will see that when the base is positive, the graph will moving upward from left hand side to right hand side. Okay, and when the value of a increase, it will keep moving up faster, So you can see that when the value of a change, the graph will always pass through the same point. That is this one, 0, 1. It always pass through this point, 0, 1. Or you can say the exponential graph will always passes through, cut the y-axis at 1. Some of you may even say the y-intercept of this exponential graph is 1. That's also correct. How about when a is less than 1? Okay, so we try to keep decreasing the value of a. And you can see that when a equals 1, it will become a horizontal line. Because when the base is equal to 1, 1 to the power x is always equal to 1. So it will form the horizontal straight line. Okay. And how about a is less than 1? For example, when a is 0.7, then you will see that the graph will start moving from left hand side to right hand side, moving downward, okay, with downward trend. Why? Because when x increase, then as the base is lie between 0 and 1, the value will be decreasing. So you can see that when a is lie between 0 and 1, and I keep multiplying the constant less than 1, then it will keep decreasing. Some of you may think, oh, whether the graph will touch the x-axis, actually it's not. For example, this case, 0.3 to the power x, you will see the graph is moving downward. So try to look at the number 10. 0.5, 0.3 to the power 10. That means you are multiplying 0.3 to the power 10, something like this. Then you may find, oh, it's very close to 0, right? But actually, you will know that it is greater than 0. Let me take more decimals. Then you can find that it is very close to 0, but actually not equal to 0. All right. That means no matter how x is large or not, it is always positive. So you will see that the graph is always above the x-axis, always above the x-axis. Okay, that's the same thing when a is greater than 1. So how about when a is negative? It does not define when x is negative. It is not defined when x is negative. Because when x is negative, when a is negative, then the power x you take here, it will always fluctuate the sign. When x is even number, they will become positive. When x is odd number, it will become negative again. So it will become fluctuated, okay, and the function is not defined. Therefore, the exponential function is only defined when a is positive. Okay. Also, a is equal to 1 is a special case we will not consider. And so that's the situation of the exponential graph. And some question will ask in this way. They will give you more than one graph to compare. Okay, suppose this one. That is y equals to 4 to the power x. Okay, the red one. And the green one will be fx equal to 1.8 to the power x. But in exam, they would not give you the name. They would not give you the name. They just omit the label. They just give you this. Okay, they just give you this. Then the question wants you to find out the base. But the problem is how. The problem is how to do this. we can do in this way. There's a trick. You draw a vertical line x equals 1. You draw a vertical line x equals 1. Why? Because when x equals 1, then the value of y will be a to the power 1. That is a. That's the special way to find the value of the bases. For example, when you consider the green line and the black line, the intersection is here, 1, 2. That means when x equals 1, the y coordinates will be 2. And you can find out that the base is 2 here. So this graph is y equals to 2 to the power x. Another one is when you look at the red line and the black line, when you find the intersection, then you can see that the intersecting point is 1, 4. That means when x equals 1, then the base will equal to 4. So you can deduce that the red line is the exponential function y equals to 4 to the power x. That's the base. Okay. For example, when I change a equals to 3, so you can see that it will cut with the black line with the intersecting point 1, 3. So that's a very good method to find the base, okay, and compare the value. Even though the question did not give you the axis value, you can compare these two graphs. The red line is higher than the green line, so you can guess the value of the base of the red line is greater than that of the green line. All right. One more thing, that is the graph of the y equals 4 to the power x, and okay, I change to 2. Okay. Now I move a becomes 0.5. That is 1 over 2. If there's a red graph y equal to 2 to the power x and another graph y equals to 1 over 2 bracket to the power x, then they will reflect to each other. They will reflect to each other along the y-axis. They are the refractional symmetry to each other along the y-axis. Just like the mirror image. Okay, just like the mirror image. Okay. So how about when is equal to 4? Then the refractional image will be 1 over 4. That means 0.25. Or how about when gx equal to 10? Then the refractional image along the y-axis will be a equal to 0.1, 1 over 10. Okay. And finally, this point, no matter what value of a is, it always passes through the fixed point 0, 1. So that's the end of this video, and I hope you enjoy this.